Okay, this is a YouTube on the Newton's Laws prelab that we're going to be doing next week. And so over on the left here, there's a synopsis of the prelab. And the situation is that there are two masses hanging from a string, one on one end of the string, one on the other end of the string, that go around a frictionless and massless pulley. And the string is massless, and on the left side we have a 1 kilogram mass hanging, and on the other side we have a 2 kilogram mass hanging. And so what you are to do for the prelab is to draw an appropriate coordinate system, draw a free body diagram for the 1 kilogram, and a free body diagram for the 2 kilogram mass, draw the direction for accelerations for each mass, write Newton's second law for the 1 kilogram mass, write Newton's second law for the 2 kilogram mass, and finally solve these two equations for the acceleration and for the unknown force. Okay, so over on the right, this is followed through. So here is just a copy of the picture of the pulley with the two masses. The coordinate system is very simple, just a y-axis with positive direction going upwards. That's the choice that I'm going to make. And so right here I have a free body diagram for the 1 kilogram mass. The 1 kilogram mass clearly is going to accelerate upwards. So I have an A pointing up. This dot represents the 1 kilogram mass, which is going to have a 1 kilogram times 9.8 meters per second equals 9.8 Newton downward force corresponding to the weight. And then there's an upward force of tension on the string. And so the tension is larger than the weight, and this 1 kilogram mass is going to accelerate up with acceleration A. But to get the full picture, we have to do the same process for the 2 kilogram mass on the other side. And for that now I know that if the 1 kilogram mass accelerates upwards with positive A, the 2 kilogram mass is going to accelerate downwards with negative A. That corresponds to this arrow that I've drawn here. And the weight for the 2 kilogram mass is going to be 2 kilograms times 9.8, which is 19.6 newtons. And so those are the two free body diagrams. Okay, so now let's write a Newton number 2 for the 1 kilogram mass. Newton number 2 says the mass m1, so I'm going to call this m1, times the acceleration of that mass is equal to the net force. Net force is T minus W1. In other words, it's T minus M1G. W1 is the weight of mass 1. M1G is the weight expressed in terms of its mass and the acceleration of gravity. And if I solve this equation for T, the unknown tension, I get T equals M1A plus M1G. Now, quick aside here, you notice how I have the same tension upwards on the 1 kilogram mass as I have upwards on the 2 kilogram mass, and that corresponds to the fact that in massless string the tension is going to be the same at one end as on the other end. Think of the string as a spring. If you pull a spring apart, if you held a spring horizontally and pulled it apart, you'd have the same force pulling in one direction on one hand as you'd have pulling the other direction on the other hand, and a similar situation occurs here. Okay, so the Newton number 2 for the 2 kilogram mass is minus M2A, minus because this is a minus A now, equals T minus W2, same tension here, acting upwards on the 1 kilogram mass, minus W2, so that's M minus M2A equals T minus M2G. And now what we're going to do is we're going to take this tension that we solved for in the first Newton number 2 and plug it in here, which is what I do in the next step. So you can see the T has become that. Then some simple algebra. I get the all the terms that have A in them on the right, and I factor A out, and I get all the terms that have G in them on the left, and I factor the G out, and I solve for A by dividing through by M1 plus M2. So A is equal to M2 minus M1 over M2 plus M1 times G. So I'm going to put the numbers back in now. M2 is 2 kilograms, M1 is 1 kilogram, so it's 2 kilograms minus 1 kilogram over 2 kilograms plus 1 kilogram times G. And so in other words, that's 1/3 G. 1/3 G is about 3.3 meters per second per second. So now if we have A, we can come over here and solve for T, which is that the unknown force alluded to over here. So T is equal to M1 times A plus G. Well, A is what we just solved for. That's this. And G now is re-expressed in terms of the common denominator M2 plus M1. And so if you look at what I have inside the brackets here is I have M2G plus M2G, giving me a 2M2G, and I have minus M1G plus M1G. Those terms cancel, so I get just get the 2mg in the numerator. So I get for the tension 2 times M1 times M2 times G over M2 plus M1. So in other words, that's 2 times 1 kilogram times 2 kilograms divided by 2 kilograms plus 1 kilogram times 9.8. And so it's 4/3 times 9.8, which is 13.1 newtons. Okay, so that's the pre-lab for the lab that we're going to do on Tuesday. I'd like you to be comfortable with this. I'm using Newton's second law and Newton's second law from the last day or so of lecture in my class is acceleration is equal to net force divided by the mass.